Okay, this one is the diameter. Then, from the center of your circle, you join to one point on the circumference. This is called radius. The girls behind, Latika is in front. From the start of the class, I already say if you don't have, collect. You all talk. Okay, wait. Okay, then what is QR? This QR is the line joining 2 points on the circumference. So it's called the chord. So, is diameter a chord? Yes, is the line joining any 2 points? A diameter is the longest chord of a circle. Okay, it is a chord and it's the longest one. Okay, so we recap chapter 9. From the center, if you slice out a cake, it's called a sector. Okay, one small segment of a circumference is called an arc. And then this piece of your sector, if you take out the triangle, whatever that is left over here is called a segment. This thing here is called the segment. It is always sector minus triangle. Okay? Then, from the sector, just to let you know, this is my sector, a minor sector. If I take away the triangle, this is my minor segment, right? The remaining big slice is my major segment. So take note of the difference between minor and major segment. Okay, then minor sector and major sector. So take note of the difference. Sailesh, what are you doing with that thing? That what stress ball? Why now everybody got one keychain? Is it a new trend of Gen Z? Why I got one student from when I was walking into the school, the students' bag all filled with keychain and selling keychain, y'all. Oh, that's the dinosaur you draw. What about the rest?
I think you don't need to know the other one.
Why? Is there something that I need to know?
Okay, is the other one is just a can. And then
If you want to spell also can. Brandon and Kiran, focus. So this is your property 2. The 1, 2, 3 don't matter. You just need to remember the reasoning. Okay, what about the second one? They say M is the midpoint of the chord AB and CM is a perpendicular bisector of the chord AB. So you have a perpendicular bisector here. Find the radius of the circle. Which one? Okay. So first thing first, this whole thing is 30. So Janisa say I divide by 2 first. So that means to find BM, I will divide 30 by 2, which is 15 cm. Okay, because CM is the, or you can say M is the midpoint. That's why you can divide by 2. So I know this is 15 already. Okay, I'm also told that OM is 9. So how to find R? Yes, use Pythagoras theorem. So to find radius, I will use Pythagoras theorem. So 9 square plus 15 square square root. What's the answer? So 5 lah. Okay, next one. M is the midpoint of the chord and HK is the perpendicular bisector of CD. So I have a perpendicular bisector. Then they tell me this is 30. They tell me this is 9. So how to find radius? How can I do this question? What should I find first? CM. Okay, cannot. Ufa, go back. Cannot. I give 3 chance already. It doesn't work out. No, sorry, it doesn't help. No, you are no. I cannot. I keep hearing you talking to May, then May convey your message. Further. Align with Yoon. Align with Yoon. Further. Okay, so CM is 30 divided by 2, which is 15. Where independent? If you cannot see, move forward. Shift away from me. It will help you.
Midpoint.
I'm not blind. Okay, so this is 15. Okay, this part here is 15. Then, based on the info I know, it seems that I don't have enough information. But you want to have a relationship between this line, and this line. These 3 sides. Sam, further. Soumya, you're in front, right? No wonder talking. Come forward. Now you all know why you all cannot sit together. Because the moment you are together, I keep hearing your conversation. Chloe? Okay, you haven't talked. I will watch. Come forward. Okay, so if we look at these 3 lengths, I know this is 15. I have no information about this or this at all. No information. But actually what I can do is, I can let this thing be R because this is my radius. Okay, so that's one unknown. But if you observe carefully, this whole thing is also R. This is also my radius. So actually OM is R minus 9. So this part here, OM, is just R minus 9. Then can you see now you only have one variable and you can use Pythagoras theorem one more time. So we will do Pythagoras theorem. R square equals to 15 square plus R minus 9 square. Okay, so let's try to solve them normally. Okay, what is 15 square minus 81? 15 square minus 81. Plus 81, sorry. This one how to get? You can do this. Then you expand. Okay? Then you will get these 3 terms. 306. Okay, so to find radius, it's just 306 divided by 18. What do you get? Why you all doing red foul? Nice answer, huh? Oh.
She just did that in like seconds.
Yes. How I get 8R? 18R. You use this one. R times R, R square. R times 9 minus 9R. Minus 9R again. Then minus 9 times minus 9 plus 81. So you will get here minus 18R. Can I?
No.
Okay? So remember, the property is not difficult. You just need to know when to use it. Ufa, you doing the right thing? I hope I'm not seeing a phone. I hope that's a calculator. I pray that it's a calculator. Okay, last one. No, second last one. Okay, I have radius that is 5 cm and a chord that is 8. So first one, can you find what is x for me?
What's it down to?
Y. Y is x equals to 8.
Because the distance, because it's the same.
What property is that?
The third one. Equidistant
The
from
third one.
center.
Equal chords equidistant from center. They already tell you the distance from the center is the same. So the chord must be equal. So that's why you know it's 8. Aiyo, why you all cannot stop talking one ah? Kiran? Don't call him, don't talk to him. Okay, so last one is y. This distance I know is the same as this distance.
I know.
So how can I approach the question?
You find the use one, right? 8 divided by times.
Okay, so I'm hearing that I should divide the 8 by 2 to find this to be 4. But how come I can divide by 2? What is the reason?
It's from center. Perpendicular from center.
Correct. So this line is perpendicular from the center. So perpendicular from center will bisect this chord into half. So you can tell me that this line here, let's label it as CDE. So you can say DE. Okay, I really don't want to be angry ah. Okay, so it's 4 cm. Okay, if you don't believe, right, you ask your friend to talk, then you see here, I can hear. If I can hear, all of them can hear what you're talking about.
Rebecca, can you hear me?
Yeah.
I said hello, do you hear that?
You didn't say
Okay,
hello.
so I'm saying that if I can hear from here, means everybody in between us can hear your conversation. So can you please be considerate? I know you want to talk to your friend, but your other friends don't want to hear what you're talking about. Oh, I don't know why every day during my lesson you all fill bottle, fill toilet with your whatever. Okay, please be considerate. Please keep your conversation to break time or when you go toilet. Just not during the lesson. Okay, so DE, you have it. The reason, like what they say, is property 2. The perpendicular line from the center will cut this into half. So write that down. Perpendicular from center bisects chord. So write the reason why you know it is divided by 2. Okay, now you zoom into the right angle triangle. This is y, this is 5, this is 4. So 5 square
minus 4 square.
equals to y. Then you take a square root. So it should give you a very nice 3 cm.
How did you know that?
Because 3, 4, 5 is a Pythagorean triplet.
We just need to say that Miss Huang is a math god.
Okay, so the property will come into handy. Although some of you say, no, it's common sense. I just know divide by 2. No, you have to tell me where is the source of your common sense. So called property, there's 3. Sorry?
Why is it minus?
Because at the start, we will always write c square equals to a square plus b square. So I'm skipping a bit of steps here. I'm bringing this over. Then I take square root. Yeah, so that's why it's minus. I bring this over, become minus 4 square.
I always just thought like if it's not hypotenuse, it's minus. If you want to find hypotenuse,
Also can, you can think of it like that. Okay, so practice 2, last question. I have A, B, C, D on the circumference of a circle. M and N are midpoint. Midpoint straight away will cut this into half. Okay, and then it is given that BM is 5, OM and ON is both 3 cm. So this one 3, this one 3, this one 5. So that's all the info they give me. They say, can you find what is CN?
5.
Why?
The number 2.
No, you first need to say the equal cos.
So we first have to write down CD is equals to AB, which is 10 cm. This is equal chords, equidistant from center. So this is the first property that allows me to know that this whole thing is also 10. And then why is it half? You can either use property 2, or to make it easier for you, you just tell me it is midpoint. Okay, N is midpoint of CD. Okay, so you cannot just straight away tell me, oh, CN is 5 cm, no reason, no steps, and then you expect to get 2 marks from there. So you have to tell me the reasoning. Okay, last one. I want radius. So again, you should see a Pythagoras theorem here. O, C, and N. This is 3. This is 5. I want to find radius. So let's use Pythagoras theorem. Radius square is equal to 3 square plus 5 square. So radius is square root 5.83. So 3 SF. Okay, so it's just these 3 properties. You see when you can use which one. I don't see you all tomorrow. Okay. So the PMP you can do during the holidays. Yeah. I say you can do. I never say you must do. Okay, but it's good to do. I say you can do. I never say you must do. Okay? Okay? So you will see in some textbook they use this. This one to mean center. Okay? And then this one to mean circumference. Okay, you know mathematicians are lazy. They always like to draw to represent symbols. But if you see it, Some books use this, but spelling is fine. Oh, this, they only give one question. Okay. Should have more variety for you all to see the different pattern. Okay, never mind, there's PMP behind. Later you'll see. Okay, so this one is quite, this is the toughest type for this property. Because students always choose the wrong angle. They match the smiling one with the frowning one. They always go and have this. That's why they like to test this one. Okay, so all 4 cases can test you on this property. So it depends on which case they want to test you on. Bring this example here and ask you to spot the difference. Okay, next one. This one is also an extension of the property just now. This is called my angle at center. This is called my angle at center. This is called my angle at circumference. Can you see it's also double? Okay, but they give a special name for this. They call it angle in a semicircle. Why? Because it cuts. This one must be the diameter. So for this case, you must be given diameter. If you don't have diameter, you cannot use this angle property. So if they give you diameter already, and then they say they join to an angle on the circumference, that triangle you see will always be 90-degree triangle. So example I draw here, I say let's meet here. This will be 90. Yeah. So here, I say let's meet here. It will also be 90. Okay, doesn't matter where they meet. At the circumference, it will always be a 90-degree if this is a diameter. So this property is called angle in a semicircle. It's a special case of the property just now. Special case. Yeah, special case. That's why they put here special case. Okay, let's try example 2. What can you see here? My goal is to find the blue angle. What do you think we can do first? Then this one? So what do you think we can do first? Find the angle at O. So if I know O, I can find the blue angle. But how to find this angle? How do you think I can find this angle AOC? Yes, radius. So since these two are radius, then this must be 38. So you can write OCA is 38 because of base angle of isosceles triangle. So since that is 38, I can find AOC already. AOC is just 180, take away the 238. So now you know this is 104. Do you see your butterfly or bow tie? So the butterfly or bow tie tells me that the angle at center is double the angle at circumference. So you can write ABC is 104 divided by 2. Reason, angle at center, 2 angle at circumference. So this chapter is like your angle properties in lower sec, but we involve a circle. Justin, you following? So this is a chapter that you need to stay calm and stare. So So you look at this one. What do you think you can use to find BAC, the blue angle?
The one we just did this question.
What is that property called?
Angle in a semicircle.
Angle in a semicircle. Okay, because I have diameter. This is a very important info. I have diameter. So any triangle I form in the semicircle will be 90 degree. So you can write angle ACB. Kiran, why? Is 90 degree because of angle in a semicircle. So once you know that, then finding the blue one should be simple. Just 180, take away the 90, take away the 65. Sum of angles in a triangle. Okay, you need not write the reason. I keep writing because we are practicing in case they ask you to write. Is it 35? 20, right? 25. Okay, so if you have all the different angle properties in your mind, when you see the question, you will know what to do. Ufa, don't give up on this chapter. It's easy. Okay, remember, you all are students. So your goal is to master every chapter. What? No? Okay, next one.
No.
What can I use in this question? Angle in a semicircle again, because when you see the keyword diameter, straight away any triangle that you form must be 90. So go and write that down. DAC is 90. Angle in a semicircle. Okay, then next one, they give you a parallel line, must have its purpose. Alternate angle. So you know that this angle here must be 25. Go and write that down also. So ACD is 25. Alternate angles, AB parallel to DC. So finally, they say find ADC. Then should be very direct already. Just 180, take away 90, take away 25. Okay, I'll give you a... No, 5 is too much. 2 minutes break. 2 only, 2 only. So, 5, 7. 2 minutes already. It's very fast. Okay. Okay, let me bring just now the property that we had
I know.
just now. What do you think is the difference between this butterfly and this butterfly?
I think it's not in the center.
Which one not at the center? Everything?
No, the end one of the end one.
So can you see that one of the point is not at the circumference, but this one, all four, is at the circumference. So this one is super important. This is where teachers like to trap you. Okay, see carefully, ah. You know, teachers teach you 1 hour, you go back, you must self-study 3 hours. So better pay attention for 1 hour to save 3 hours. Chloe, you look like you are in a meeting. Now you all know, no? You all understand why, no? You all cannot sit with your friend. Because you all sit there, you gone. The whole lesson gone. This is why you all don't like to hear us say it's for your own good and it's really for your own good. You see, I separate Ufa, she sleep already. So what should I do? I put her there, she talk, sacrifice all this, cannot pay attention. Or I leave her there, so she sleep, she sacrifice herself. How? Every day I have a struggle. I kill one, remind everybody, or I kill myself. Means I ban all my principle lah. I just allow you all to do what you want, so everybody is happy. Or I make one person unhappy, so that at least other people can learn. So I'm saying, can you all please understand the teacher's perspective? You stand here, you know, you can see. So please, okay, I want to highlight to you all, please see. I'm showing you the difference now. During exam, you all anyhow. Everything also angle at center, twice angle at circumference. Anything also angle in the same segment. So can you see these 4 points? Right, like drone like that. Drone, ALP student, SYFC. Do you see a drone? Do you see drone? You cannot find. Okay, anyway, this 4 thing, right, must touch the circumference. If one of it, unfortunately, is not at circumference, it's a different property. This is angle at center, twice angle at circumference. Please see the difference. This is the center. This one. Center. Okay, but all these 4 all at circumference. So when you form a ribbon, where all 4 points are at the circumference, is called angles in the same segment. Why? Because can you see that the base, they all lie in that same major segment, or they all lie in the same minor segment. The whole ribbon is at the same segment. So we call them angles in the same segment. The 4 angles all in the same segment. And what is powerful about this is the same side of their wings will always have the same angle. So that means this angle is the same as this. No.
Make them suffer. Don't eat.
He doesn't make it.
So these 2 part of the wings, okay, go lah. These 2 part of the wings have the same angle.
Wait, then the other side.
Also same.
So like,
Different. Wait, is it different?
But they could be different in size.
you know what?
No, wait.
No,
like all 4 of them are the same or like
No,
the
the pair of them are the
So
same.
D, C is same, not B and D.
Yeah. So please, the top part of the wing same, the bottom part of the wing the same. One from each wing, you don't take the 2 angle from the same wing. Then I don't know what to say already. So I thought it's quite clear already. Top part of their wing, same angle. Bottom part of their wing, same angle. So look at this one. What is the angle ABD? Ufa. What is the angle ABD? Same part of the wing. Like got one cartoon wings, right? Same part of the wing. What is ABD? 35. So these two wings are of the same angle. Then you write angles in the same segment. Must tell me the reason why they are the same. Justin, what is this angle BDC? Same part of the wing. $50. So remember, the same bottom part of the wing and the same upper part of the wing, they are equal in size in the angle. So you also tell me angles in the same segment. So just have to identify like that. Okay, next one. I have a diameter. I have BCD. I have ADC. I'm interested in finding BDC, the pink angle. So how can I start off? How can I start off? My ultimate goal is the pink angle. So how should I start?
That thing is 90.
First, I have diameter. So what does it tell me?
ACD is 90.
Okay, ACD is 90. So straight away I go and write here. This one is 90. So angle in a semicircle. I write down first. I don't know where it leads me to. But because of this, it also tells me that this is 20. So I can write down BCA is then 20. This one no reason. I'm just taking a difference between two angles. So that is 20. So if I know that part is 20, is there a butterfly I can find? So can you see the butterfly here? Where all 4 points are on the circumference. So bottom part of the wing must have the same angle. So which tells me that this one and this one, they are both 20. So I can write down ADB must be 20 also. This part here. And this. Bottom part of the wing.
Then you 40.
So I write, this one is what? Angle in the same segment. So to find the pink angle, I just take the difference. So therefore, BDC is just the green one. Take away my 20, which is 40. Okay, so they can mix a lot of property in one question, but you do part by part. You what? Lesson over.